So hi, and this is a new episode. So I've got this new Liitokala cells. This is 18650 batteries, lithium cells. By the way, Liitokala, or whatever you pronounce this name, has many different cells. You can see the brand here. So we have LII 20S, and from 20S up to 35, which means that this version, this is the 25, the 35 is the highest power rate they currently have. And I think that these cells compared to VTC6 or the Sony high power drain cells, and they can be suitable for all power application such as driller, corkinet, scooters, etc. So what I would like to do is first to see how it looks, and then of course to do some testing. The current should be 3100 milliamp hours, which is a lot for such a battery. And of course we will test it also. So I have to admit I've already opened this box. Each box contains 2 cells. This is how I got them, and they are packed very well because of the high current, so you have to be very careful about the packing of these cells. So as you can see, 3100 milliamp hour, 35 amp continuously, and we will test to see if it can handle such high current. And of course we will also test, by the way it's written LII 31, and LII 31 is 35 amps. I would expect the number to be the currents that it can handle, but probably there is no connection between the number and the real current. So what I will do first, of course, charge them to maximum 4.2 volts, and then we will do a low drain capacity test about 1 amp to see that it can reach the current, to see that it can reach the capacity that is written 3100 milliamp hour. And then we will do high power drain. I doubt if I can test it at 35 amp, but at 20 amp for sure I can test them, and I will try to go a little up. Of course, when we are consuming such a high current, so the capacity will be lower. Actually it's not really lower, it's because of losses in the wires and in the heat. But we will see, we will try several tests to see the capacity. And Liitokala is a Chinese manufacturer which has a very high quality product. I've shown before other cells, lithium phosphate of the same vendor or manufacturer. So let's start. And of course we will have to weld some tabs, because we cannot consume high current without connecting a very good connection. It's dangerous, it's heat, and we want to avoid of course any overall heat. So during the test I will have at the high current to measure the temperature, and probably if it's exceed 50 Celsius degrees, or about 50 or 60, I will have to stop the test. And that's all. So let's start. So as always I'm using my favorite welder, spot welder. You can see my previous videos why. Okay, so now I will put the cell, and I have already one tab. I will cut it, and then I will weld it to both sides. Maybe we'll start with the negative, and then we'll move to the positive, and then we will continue from there. So I will use scissors in order to cut the sharp edge. Okay, so now, as always, using the module magnet to catch the nickel strip at its place. And now we can move to the welding. Okay, so I've set to 40. I think it's enough. As you can see, because I set, by the way, as you can see, it's very strong welding, and the interval time is why it took it so long. So I will move it to half second, and we can see that it's too much current, so I am reducing it a little and moving to the other side. This welding is very strong here, so let's go to the positive. As you can see, a very strong weld. This is more than good enough. By the way, when doing it, I always love to add a capton, although there is, of course, we have the layer of the battery, but in order to add an extra isolation from attempting to do a short from the positive to the negative, so it's a very good thing to put additional capton tape beneath this part of the nickel strip. So I will add it, and now we are ready to start. Next thing is to measure the voltage that it came with. Usually they never send it, of course, fully charged. This is from safety reasons. So usually you have between 10 to 20% up to maximum 50. So let's see how I got this cell. So 3.72. 3.72 is about, I guess, 20 or 30% charge. So now we will charge it up to 4.2 volts, and then we will start the discharge test. Okay, so of course I will now use a current limit charge 1 amp, and then we'll continue from there. So after rereading the specification of this battery, it turns out that the maximum discharge is 25 amp continuously, and the 35 is also a number, but this is a peak current. So basically what I'm going to do, I'm discharging it with maximum 25 amp in order not to go over the maximum allowed current. And now we will test it. Is during the charge now, but it is almost complete. So we can see when it is connected we have 4.18 volt. So soon we will do the slow discharge rate to see the real capacity, and afterwards we will move to the high current charge rate, and we will see what the temperature is during this high current discharge. So the battery is now connected. Now I will apply power to the charger. I set it to minimum 2.7 because this is what is written in the datasheet. I will connect a 30 amp fuse that I've already prepared, and now we will do a low current discharge. So I will put it maybe in a bigger screen. We'll set it to 1 amp. And I will First, what I did, I reset the current, the capacity test number to see the real capacity. So now we're discharging, and let's wait and see what is the real capacity of these cells. So you can see that the voltage is now close to 2.7. The capacity is 2.71 amp. The rated capacity is 3100 milliamp hour. This is a little less, but I want to remind that I did not fully charge to 4.2. I would say I charged to 4.15. So probably the rated capacity is okay. And I will stop it now and then do full charge again to see the charge capacity. I can also see how much capacity is entered into the cell during the charge, and then we will go to high current mode discharge, and we will also measure the temperature during this point. And another test that I want to do when it is fully discharged or close to fully discharged, let's say, I would like to test now the impedance of this cell to see what impedance is rated. I would expect something near 20 milliohms, but during when the battery is fully discharged and when the battery is fully charged, the value can be different. So now when it is fully discharged, it can be higher impedance than when it is fully charged. So let's maybe test it. First, plug out the fuse in order to disconnect. Now we will do this test. Okay, so let's see what we have. So we have 14 million. Wow, this is very low resistance. Okay, so let's now do this charge and then we'll continue from there. So now I've started to charge at 1 amp. You can see that the reading here is not accurate about the impedance. It is showing 103 milliohms and we've seen that it is 14, so you can trust the impedance measurement of this, but you can trust the current, the capacity. So we will see the capacity that this ISDT will show. So waiting for fully charge. So now it is fully charged again, and you can see 2917, which is very close to the rated capacity, and we can estimate that about let's say 5% is inaccuracy of the starting level, the low level. So basically what is rated, it's real. Now let's go and check the impedance when it is fully charged. Okay, so I now trying to find. Okay, so now let's try and test again the impedance when it is fully charged. I remind you that it was around 14 milliohms. And we can see that it is almost the same, a little less, but let's say that can be measurement error. So now I will try to discharge at 25 amps and we'll see how it goes. So the battery is in the frame, it is beeping because the fuse is not inserted yet. So I will insert our safety fuse. Maybe before this we'll add a temperature meter. Okay, so it is beeping because the fuse is not inserted. I have connected a temperature meter. The temperature is now 26 degrees Celsius. and we will do a high rate discharge. Okay, so the fuse is now in, and we will go up with the discharge current. Okay, so let's start the discharge. I'm raising up the current, so a little less than 1 amp. We are now at 6 amp, and I'm moving higher. $10 and we'll go to 20 amps. So we are now at 20 amps. We'll go a little higher. Okay, we have a problem with the voltage drop. I will set it up. Okay, maybe okay, well, I will stop it for a second and we will continue because I want to set up for lower voltage. We can see the temperature is already rising on the cell when it was 20 amps. We will go higher again. I don't want to go over 50 degrees Celsius because the cell is very hot. So we are at 23 amps. Let's go to 25. I can feel the cell is very hot now. The temperature is not correct. I will reduce now the current to 20 amps, but we can see that it can hold for a few seconds, let's say. With the 25 amps. Cell is getting very hot. It looks to me that the temperature is not measuring the accurate temperature. I don't want to go above 50 degrees, so I will reduce now to 10 amps, maybe 15. And our cell is very, very hot. Okay, because I've already reaching 60 degrees, let's reduce the current and see when the cell is temperature is getting lower. So I wouldn't say that these cells can really handle 25 amps. It's at the edge. I can barely touch it. Very wow, very hot at this stage. But we can see that we already consume 1 amp of the rated capacity, which is 1/3. Wow, the cell is still getting very hot because of the few seconds with the very high current that we consume. As you can see, it is still going up, which means that I wouldn't trust using 25 amps from one cell. Maybe if you put 2 cells in parallel, this is not a problem, but consuming from one cell the 25 amp is a little problematic. I will wait for it to cool down and then we'll do a complete 10 amp discharge and see how hot it is. So I will wait for cooling down. Okay, so the temperature decreased to 29.4 degrees Celsius, and I have added a fluke to measure directly the voltage on the battery, since this one is not very accurate, and after the load of the current it will drop dramatically compared to this one. So again, I will go to 10 amps and we will see the temperature and how it goes. So I will try to go as fast as I can, because I want to make sure that it can handle this rate of load without any issues. So we are at 10.4 amps. You can see that the voltage here is much greater than measured on the load, because the load is measuring after the wires, and we have a drop of a few hundred millivolt on the wires and on the fuse also. So we can see that the temperature is starting to increase, and what I would like to see is that before I'm reaching the minimum level, which is 2.7, the cell is not getting too hot. By the way, you can calculate exactly the power dissipation, because it's I multiply by itself and multiply by the resistance that we see that it is 14 milliohms. So this is 100 times 14 milliohms. So this will be 1.4 watt. I'm mistaken, or I'm correct? Let's see that I'm not mistaken. So 100 multiplied by 14 milliohms. Yes, we have 1.4 watt dissipation power on the cell itself. 33 degrees is not any issue. You can go up to, let's say, 50 degrees Celsius safely. So I wouldn't be worried about getting even to 45 or 48 degrees Celsius. It's not an issue for these cells. We can see that we are still in the safe rate, because the voltage do not drop below 2.7, which is the manufacturer. On the manufacturer page I seen that the minimum voltage for these cells is 2.7. Usually on lithium we say that it is 3 volt, but if the manufacturer is saying that 2.7 is safe, so it is safe. We can see the capacity is now 1.6 amp hours. Of course we have a drop. It will not get near 3 amp hours because we have all the heat and dissipation and the losses on the wires themselves. So if you, let's say if you will get above 2.3 amp hour on this current, I think it is okay. You can see well, it's 38 degrees Celsius. We are starting to get to the minimum voltage. You can see 3.16. We have another about 400 millivolt. We can go down. The cell is getting heated. Yes, it's very hot. But it's still reasonable. I wouldn't worry about it yet. Two amp hours. We don't have much capacity left. Again, we are not close to the 3 amp hours because of the high current rate, which decreased dramatically the capacity the real capacity that we can actually use. (42 degrees), it's still very safe. So I would say that these cells can handle between 10 amps continually to 15 without any issue. I wouldn't go to 25 amps. Maybe you can use 25 amps for a short period of time, let's say a few seconds, and then stop this high current rate. And by the way, we did get with this high current to 2.2 amp hours already. We are close to the voltage that might harm the cell, but we are still good. We can see that we will not get probably to 50 degrees Celsius. Maybe at the end, when all the capacity is out. I mean, it is still getting hot. Even if I will close it now, you will see that the temperature is still rising. The cell now is very hot, but it's still in the safe temperature, I would say. Wouldn't worry about it. Okay, the voltage is dropping. I'm looking, of course, at the direct measurement on the cell. Cell is very hot and we are close to the minimum voltage, so I will stop the discharging soon. Maybe let's go now to 5 amps. Okay, I'm going to 5 amps in order, just I'm curious about the capacity. I would expect the heat now to reduce, and it is showing some signs of reducing. It's going lower as I expect. I have to say I'm pretty impressed because we are very close to the rated capacity of the cell, and this is very impressive using such a high current with all the losses and everything, and the cell continue to give us a high current out. Still, the cell is very hot. We can see now that the temperature is getting lower. It's 5 amps, no problem at all with this, as probably they will not get any hot, maybe a little. They are still hot because of the 10 amps load, and probably the steady state for 5 amps I guess is around 40 degrees Celsius. I have to say I'm pretty impressed about the capacity. It will get to 2.9 amp hours, it looks like. Temperature of the battery reduced a little. This video is long because we are in real-time testing. Okay, now I will decrease because the voltage is getting too low. Okay, so I would say 2.84 at around between 10 amps and 5 amps. Pretty impressive, I have to admit. So bottom line, these cells looks very high quality. I wouldn't use them at any case at 25 amps load. I would use it between 10 to maximum 15 amps continuous load. And if you prefer higher current, so you will have to use few in parallel, so take into account each cell about 10 amps is very safe to use. Hope you enjoy. I will leave a link where to buy them, and thank you and bye.